In this video, we're going to talk about factoring the difference of squares. What is the difference of squares? It's when you have two terms. It's when you have a minus sign between the two terms. And the two terms are perfect squares. So before you can use this method, you first have to determine if they are perfect squares. So let's go through the steps. The first thing you do is there has to be a minus in between the two terms. Also, there are only two terms when you have difference of squares. You look at the first term. That first term, is it a perfect square? How do we know? If we can take the square root of the number or of the variable and we get back a whole number. So can I take the square root of x squared? Yes, and I will get x. Can I take the square root of 16? Yes, you get a 4. So everything checks out. I have a minus, I have two terms, and both terms are perfect squares. That means that this is a difference of squares, and this is how you factor difference of squares. The setup is you have two parentheses. That first value that you took the square root of, that goes here and here. That second value goes here and here. And in between, one of them will be a plus, the other one will be a minus. And this is how you factor the difference of squares. This would be your answer. You can do FOIL or do the distributive property to check to make sure that you get back what you had originally. Let's look at a second example. Before you start factoring, determine if this is a difference of squares. The first thing you look at is that you have to have a minus in between two terms. We have a minus in between the two terms. Second thing is this a perfect square? How do I know if it is? You take the square root. If you get a whole number, then it is. So can I take the square root of 9? Yes, it's a 3. Can I take the square root of x squared? Yes, it's x. Can I take the square root of 25? Yes, it's 5. So now I can set up the factorization. This 3x is that first term inside your parentheses. The 5 is your second term, 5 and 5. And in between these two terms, one of them goes with a plus and the other one has a minus. And there is your answer. Remember, you can check to see if you get the original expression. Now I want to show you this example, and be careful with this. 6t squared minus 36t. It has a minus. It has two terms. But this is not a difference of squares. So be careful. How do I know it's not? Well, this first term is not a perfect square because I cannot take the square root of 6 and get a whole number. I will get a decimal if I take the square root of 6. So right there I know that this is not a difference of squares, even if I can take the square root of t squared and 36, but I can't take the square root of 6. So this does not qualify as a difference of squares. What do we do to factor this expression? We have to do the greatest common factor method that we already saw in a previous video. And here's what you do. You take that first term and you make a list of all of its factors, which is 3 times 2 times t times t. You take the second term, which is 36t, and that equals 3 times 2, that's 6, right? Times 3 times 2, another 6, because 6 times 6 is 36, times t. Now we look at the common factors. Which are the common factors? Well, they share a 3. They both have 3 as factors. And both terms have a 2 as factors. And both terms have a t as a factor. So these three things that I circled, I will multiply 3 times 2 times t, which are circled, and that will be the factor that goes outside the parentheses. So this is 6t. 3 times 2 times t is 6t. That is the monomial that goes outside the parentheses, and then I open a parentheses, and what's left of that first term without being circled is t. That's your first term inside the parentheses. I have a minus here, so minus here. And then in the second term, what's left that's not inside a circle is 3 times 2, which is 6. And there you have it. You have factored that expression, okay? And if you check, 6t times t is 6t squared, and 6t times negative 6 is negative 36t. So this is correct, okay? So be careful. Just because you see two terms, that doesn't mean it's a difference of squares like these two examples. So you have to be very careful and look at what you have, test it out. Now I want you to practice the difference of squares. Here are the 3 problems I want you to work on in your notebook, and then come back and check if you get the answers correct. I hope you do. In our next video, we're going to talk about finding the zeros of a quadratic function, or solving a quadratic function by factoring. So now we're going to use everything you have learned about factoring to solve quadratic equations. So I'll see you in the next video.